Hello, welcome. This is CH Arvind Kumar, Assistant Professor, Department of Computer Science and Engineering, Vagdevi College of Engineering. I am going to explain Network Security and Cryptography Lab. V3 program. Write a program to implement Playfair Cipher. The Playfair Cipher was the first practical diagram substitution cipher, and this schema was invented in 1954 by Charles Wheatstone, but was named after Lord Playfair, who promoted the use of cipher. First, we'll start with key generation. The key sequence is a 5 by 5 grid of alphabet that acts as key for encrypting the plaintext. Each of the alphabets must be unique and one letter of the alphabet is omitted from the table, that is J. If the plaintext contains J, then it is replaced by I. Our plaintext is Hello Arvind and our key is cryptography. By using this key, we are going to generate key sequence for encrypting the plaintext. Let's start generation of key. For generating the key, we are going to copy these key characters into this 5 by 5 grid from top to bottom and left to right. If the key contains any duplicate characters, we are going to omit that characters and we are going to copy the next unique character into this grid. For example, first we'll copy C, then we'll copy R, then we'll copy Y, and we are going to copy P, and we are going to copy T here. Then shift to next row, copy O here, then copy G. We are going to copy R here. Before going to copy R, first check R is already repeated or not. Yes, R is already repeated. That's why we are omitting this R and we are jumping to next character and we are checking the A is unique or not. Yes, till now we did not use A, so that's why we are going to copy A into our key sequence. Next, P is also repeated. That's why we are going to omit this P and we are jumping to next character H. We are going to copy this H into our key sequence. Next, Y also already repeated here. That's why we are omitting this Y. We have some empty slots in our key sequence. So what we have to do? Simple. Fill remaining alphabets from A to Z, which is not available in our key sequence. So start with A. Check A is already there. So go with B, next character. So B is not there. We are going to copy B. Next C is there. Go for next character D. D is not available here. So copy D. Next E is also not used. So copy E. Next F is also not used. Copy here. Next G is already used. H is already used. Then shift to next character, that is I. I and J is copied into the same sequence. Means J is omitted. If you have any J in your plaintext, that is replaced with I. Next K is not available in our key, so we are going to copy K here. Next L is also not there, so we are going to copy L. Next M is also not there, we are copying M. We are copying N. O is already used, so we are going to next character P. P is also used, so we are copying Q. Next we are checking with S. S is not there, so we are copying S. T already used, so we are copying U. V is not there, we are copying V. We are copying W and we are copying X. Y already used, that's why we are copying Z. In this way we are going to form key sequence. It is used for encrypting our plaintext. Now we are going to encrypt our plaintext. To encrypt the plaintext, we have to follow this step. Suppose your plaintext contains two recurrent letters. Separate the recurrent letters by using X. Example, our plaintext is Hello Arvind. In Hello Arvind, L is a recurrent character. So separate the two L's with X. Copy our plaintext Hello. After L, place X and copy next characters LOARAVIN. Like this, two recurrent letters are separated with X. Next, we are going to combine two letters as one pi. H and E is 1 pi. L and X is 1 pi. L and O is one pair, A and R is one pair, A and V is one pair, I and N is one pair. Here one character is left. In this case, we are going to pad some extra character, that is X, after this single character. Second rule, if two plaintext letters are in the same row, then that letters are substituted with immediate right letter of that particular plaintext letter. Assume if the plaintext letter is the last letter of the row, then that is replaced by the first letter of the row. Third rule is, if the two plaintext letters are in the same column, then that letters are substituted with immediate below letters. Assume if the letter is the last letter of that column, that will be replaced with the top letter of the column. Otherwise, each plaintext letter in a pair is replaced by the letter that lies in its own row and the column occupied by the other plaintext letter. By using these rules, we are going to encrypt our plaintext. We are going to apply these rules for encrypting our plaintext. Our plaintext is hello Arvind. Already we separated our plaintext into two characters pairs, HELX, LO, AR, AV, IN, DX, and already we generated one key sequence. By using this key sequence, we are going to encrypt all our plaintext pairs. Start with first pair, HE. Verify H and E in our key sequence. H is here and E is here. So both letters are in different row, different column. Here we are going to apply rule 4. If both letters are in different row and different column, we are going to replace that letters with opposite letter of that character which is in same row and same column. Means H is going to replace it with G. So the ciphertext character for H is G and E is going to replace it with I. The same way encrypt next pair L and X. Verify L and X in key sequence. L is here and X is here. So both letters are in different row and different column. Again rule 4 is applied here. That's why L is going to replace it with Q and X is going to replace it with next pair LO. Verify L and O in a key sequence. L is here, O is here. So both are in the same column. That's why we are applying rule 3. If both letters are in same column, we have to replace that letter with immediate below character. So L is going to replace it with U and O is going to replace it with D. Next AR. Verify A and R in our sequence. A is here and R is here. Same rule 4 is applied because both are in different row and different column. So A is going to replace it with G and R is going to replace it with Y. Next AV. A is here in our key sequence and V is here. So again we are applying rule 4 because both are in different row and different column. So A is going to replace it with G and V is going to replace it with W. In the same way I and N. I is here, N is here. I and N both are in different row, different column. Rule 4 is applied. So I is going to replace it with F and N is going to replace it with Q. Next D and X. D and X also in different row, different column. Same rule 4 is applied. So D is going to replace it with I and X is going to replace it with. This is a ciphertext generated from our encryption. Next decryption. Decryption is exactly reverse to encryption. For decrypting the ciphertext, we have to follow these rules. The first rule is divide your ciphertext into two letters pairs. Like this, we have to divide our ciphertext into two letters pairs. The second rule is if two ciphertext letters are in the same row, these letters are going to replace it with immediate left letters of that particular ciphertext. If that particular ciphertext letter is the first element in the row, it is going to replace it with the last element in the row. Next, if two ciphertext letters are in same column, it will replace it with the top letter of that particular ciphertext. If the ciphertext character is the top letter, it is going to replace it with the bottom letter of that particular column. And the fourth rule is if the characters are in different row and different column, it is going to replace it with the characters which are in the same row and same column. We already divided our ciphertext into two letters pairs and we have a key sequence. By using this key sequence, we are going to decrypt our ciphertext and we are going to generate plain text. Take first pair GI. Verify GI in our key sequence. G is here, I is here. So both are in different row and different column. So rule 4 is applied. G and I is going to replace it with opposite corners of that letters. letters. So G is going to replace it with H and I is going to replace it with E. Next QU. Verify Q and U in our key sequence. Q is here, U is here. Both are in different row and different column. So rule 4 is applied. Q and U is replaced with opposite corners of that letters. So Q is going to replace it with L and U is going to replace it with X. Next UD. Verify U and D in our key sequence. U is here, D is here. Both are in same column. So rule 3 is applied. If both letters are in the same column, these letters are going to replace it with top letters of it. U is going to replace it with L and D is going to replace it with O. Next GY. Verify G and Y. G is here, Y is here. Both are in different row, different column. So rule 4 is applied and G is going to replace it with A and Y is going to replace it with R. Next GW. G and W are in different row, different column. So rule 4 is applied. G is going to replace it with A, W is going to replace it with V. Next FQ. F and Q also are in different row, different column. Q is here, F is here. So both are in different row, different column. Rule 4 is applied. F is going to replace it with I and Q is going to replace it with N. Next IU. I and U both are in different row, different column. So rule 4 is applied. I is going to replace it with D and U is going to replace it with X. So our decrypted plain text is hello Arvind. In this way, encryption decryption is performed by using Playfair. This is Playfair program. In this program, first we are reading the plain text and key. By using key, we are generating key sequence. With that key sequence, we are performing encryption, and with the same key sequence, we are performing decryption. We'll see how to execute this program. To execute the program, open command prompt, compile the program. For compiling the program, use command cc space program name.c -o. -o will create an output file, and that output file is copied into a new file, that is out. Program is successfully compiled. Directly we are calling the output file, that is out.exe. It is asking for plain text. Our plain text is hello Arvind as per our example. It is divided the plain text into 2 letter space by using the first rule, and it is adding X. It is adding X in between 2 L's, and it is adding X after D also, because D is a single character. So here we are padding some extra character X. To encrypt the plain text, use this option. So I'm pressing 1. Now it will perform encryption. For that, it is asking key. Our key is cryptography. So it is generated the key sequence by using cryptography and divided the characters. For that characters, it is generated ciphertext character. Finally, our ciphertext is this one. To decrypt the ciphertext, use option 2. It is decrypted the ciphertext. The decrypted ciphertext is hello Arvind. Remove this X at receiver end. Thank you.